Okay. Good afternoon, Professor and everyone. My name is Zian, and today I'll be presenting our project progress on behalf of Group 9. Just a recap on the purpose of our project. We are focusing on the issue of microplastics, and we want to create a remotely operated vehicle to sample and measure the concentration of microplastics in the ocean water. So to look at the feedback we have received from our first presentation, first, how are microplastics harmful to us? It can contain a lot of toxic chemicals despite being extremely tiny, and they can damage human cells because they contain chemicals such as bisphenol A, and it can lead to human health illnesses such as cancer and diabetes. As for how we can analyze microplastics in the water and how we can solve the issue of limited range, I'll be addressing them later on. So let's take a look at some of the existing technologies that are being used today. In general, ROVs allow us to see and explore the ocean without us being actually in the ocean. And they can contain a lot of basic functionalities such as a still camera, a video camera, and also lights. And they can range from the size of a shoebox to a large van. We can take a look at the example here of an ROV created by Anna Du, a 12-year-old student, in the time of creation. It has functionalities of navigation and detection. It navigates through the ocean floor and it actually detects microplastics on the ocean floor. And the primary purpose of this ROV is to identify areas where microplastics are accumulating. For sampling, we can take a look at an example of the sampling frame created by the National Oceanography Center, which can measure up to 6,000 meters deep and is able to collect up to 24 samples. This seems amazing, but for the scope of our project, we will be focusing more on shallower waters, and we will be limiting the size and the number of our samples for the practicality of our ROV. We would also want our ROV to be more autonomous and be able to move further away from the shore in order for, without the need for the control stations to move with it as much. As for the microplastic testing methods, the simplest way of testing the microplastics in the water is through filtration. So basically, the water samples are collected by surface nets in the ocean water, and they are filtered in order to isolate the solid materials of different sizes. Okay, the second method is by gravimetric analysis, which is the separation of the solids from liquids, and also the differentiation of the different solid materials in the sample. Following which it will the plastic particles, especially the microplastics, will be collected manually under the microscope. Although it is very and it requires a lot of manual involvement, which is very time consuming for us, and thus may not be as efficient of a method as it seems. Another method of microplastic testing is through spectrography, which is a measurement technique using light. The first method is by pyrolysis to gas chromatography to mass spectrometry, which is the controlled decomposition of the sample, followed by the gas chromatography, which will separate the solid samples in the mixture, and then the mass will be measured by mass spectrometry. The other method, which is the Raman/FTIR spectrography, is a lot more straightforward. It actually exposes the sample to either scattered light or infrared radiation, respectively, and the spectrum produced can give a result on the concentration or the size of the microplastics present in the sample. Thus, we have decided to go ahead with the FTIR spectrography for our testing method because it can it allows for faster data acquisition, and it requires little to almost no manual input. And there are already a lot of portable instruments made commercially available today. So this seems like the most efficient method for microplastic testing, and it also saves a lot of time. We have decided on the location of sampling, which is Korean waters nearer to shore around Korea, and we are focusing on the epipelagic zone with the range of about 10 meters to 200 meters deep. For the operation of ROVs, the batteries, the supply of electricity and communication is mainly through batteries and also tethered wires. So tethered wires are able to supply electricity and maintain communication for a longer period of time through the use of cables, but it is limited by its range since it depends on the length of the wire. On the other hand, for batteries, it will help to increase the range of the ROVs, but it is limited by the amount of time it can stay underwater. So with these two limitations, we have decided to create a hybrid system involving both batteries and wires. And the tethered wires will be used nearer to the surface and also in smaller depth waters, while when ROV goes deeper down into the water, then we will switch to the use of the batteries to increase the operational range of the ROV. So this is the type of battery that we will use, the lithium-ion battery, which is more suitable than lithium polymer batteries for ROV applications. So today, we have completed the preliminary research. We have found existing technologies that can be integrated into our proposed solution, which is done by Junho and me. And we have decided on the testing method for microplastics, which is done by Ezekiel. And we have decided on the location of focus. And we have also chosen the most efficient power supply, which is done by Sungwon. And following to our final presentation, we'll be taking a look at the overview and the design of the entire ROV automation system. And we'll be analyzing the entire process of the operation, and we'll be resolving or mitigating any challenges that we face for our approach. So with that, I have come to the end of my presentation, and thank you for your time. I think we didn't want to be very ambitious because if you say that we are exploring deep waters, there are a lot of deep waters around the world, and there isn't a lot of data on Korean waters, especially the shallow waters where more microplastics are accumulated. So we wanted to find data over time on how the microplastics can accumulate over time, and then implement measures to tackle all these. Yeah.
So people out, do you have any specific plan to collect the seawater data? So are you going to the ocean, or how are you going to collect the seawater which contains microplastic?
Because our proposed solution does not have any detection system, the primary purpose of our ROV is to just collect samples from the ocean water from different points around Korea, and then we will only discover the concentration of the microplastics after we do all the measurements using our chosen method, which is the spectrography. So yeah, we are collecting actual seawater, and it will be a very long process since we are choosing a lot of sampling points. So this will be like a long-term project that we are focusing on. And we are also looking at the concentration of microplastics accumulating over time. Yeah, so over time, after we have done all these, for our first sampling, we will redo a second sampling to measure the concentration changes over time.
I planning to do yearly sampling and analysis. It takes time and money to get the device.
Yeah, it does.
Yes.
A lot of money.
Good.
FTR as compared to the other methods? Because it is the most efficient method. Because if you look at the first two methods, filtration and gravimetric analysis, these are very complex methods and it's very time consuming. If you want to collect a lot of samples, then these methods wouldn't be the most efficient. Yeah, so the other two options will be the pyrolysis and Raman, other than FTIR. So pyrolysis can also be quite tedious and time consuming. So we are focusing more on efficiency here, which is Raman and FTIR. But Raman uses scattered light, which is a fact is that FTIR has faster data acquisition if we use infrared radiation. Yeah, so that's why we decided to go with FTIR rather than Raman.
But isn't there like data that government which can be used as something which could be used?
Oh. Okay. I think we will take a look at that deeper. Yeah, we will do more research on that. Yeah, so I'm not very sure.
The first question, why water? You need to find out that microplastic also dance in color. Sometimes I don't know. I'm asking. It can be washed out to the deep water.
Yeah.
Collected there.
Yeah.
Or probably coming from the river side near the well. The shallow water still we have microplastic collection there. You need to find out.
Okay.
And the other one is AUV. You are trying to use the battery AUV. AUV, right?
It's for
you cannot switch it to ROV to AUV because it is very big difference between AUV and ROV. My suggestion is you can use a small satellite AUV nearby ROV together.
Okay.
So that they can go around the ROV to go for additional sampling. So then if you find some place of interest, then the whole system ROV and ship can move down to there. So it can be used as sensors around ROV. So you need to separate out the functions of door of AUV and
okay.
It is not easy to convert ROV into AUV exercise. That's it. Thank you very much. Yes. Yes.
Okay, let's go. So I'm gonna present you the project midterm presentation of our project. So we are team 10. So just to review, we're gonna first review the proposal project and the final project, and then we're gonna see every step of the presentation. So firstly, our proposal project was a marine debris collection system. So during the first presentation, we did some comparison of different devices And that leads us to choose ocean cleanup device as our collection system concept. And the goal of the project is to apply this system to South Korea. So during this presentation, I'm gonna present you the technology in detail, explain why we choose this technology, and start to citing the technology for location. So I'm gonna present you also the location that we choose. And for the economic aspect, we did some research, but due to the short time of the presentation, we're gonna present this during the final presentation. So allocation. So we found several scientific papers from researchers that, so one of the paper was researchers that use a Lagrangian particle tracking model to observe the motion of plastic in the Korean peninsula. So as you can see here in the chart, so here you got the rivers from South Korea. And as you can see, here the discharge particle. And as you can see, the amount of micro and macroplastic is greater in the Han and Nakdong rivers. But since we'll look only for the debris that are originating from Korea, we will choose the location on Nakdong River's region, because in Han River, we've got the green part, which is telling us that it's from Chinese coast debris. So now that we got our region, we want to narrow the region. So we did some research and we found that Nakdong rivers discharge 3,000 tons of debris per year, which is a lot. And we found that the team of researchers at Fukyong National University have been tracing the movement of plastic waste across the stream and water of the country. And they say that, I'm sorry for the pronunciation of Korean word. I'm doing my best. So it's of Goji Island, which is here, is one of the top plastic waste hotspots on the southern coast of Korea. So we actually saw that since we've got the Nakdong River here with the mouths of the river, due to the tidal phenomenon, discharge from the Nakdong River drift toward the coast of Goji Island. So this is what you can find here on the graph when you have like the direction of the tidal flow. So we restrict our location to Goji Island areas, which is like between this here, between Nakdong Rivers and Goji Island. So now that we have our location, we need to focus more on the ocean cleanup devices. So firstly, we talked like in the first presentation about the system O3, which is this system here with the graph. So the system consists of a U-shaped barrier that you can see here that catch debris and guides the plastic into retention zone that is here. So here you got two boats who like move at really low speed. And when it's full, the back of the retention zone is empty on the board of the vessel, and then when the containers are full, they are brought to shore for recycling. The second one is called interceptor original, so it's kind of the same concept. Debris are flowing with the current, get to the opening of the interceptor by a barrier that is right here. And then the current moves the debris into a conveyor that is here, and the shuttle automatically distributes the debris across 6 dumpsters, and this is one of the dumpsters here. And when the interceptor is full, operator collects the rest. And the two last one is the simplest one, is the interceptor barrier, interceptor barricade. So this one is a system with a U-shaped barrier around the mouth of a small river intercept the trash. And so you need to remove the trash from the water. And this one is kind of particular because it's for like high pressure flow. So it consists of 2 booms. The one upstream catch most of the pressure and the debris, and the one downstream catches any plastic waste or loss due to the pressure. So we did a comparison table, and since our location is not a river, but like it's a sea, so we choose the system of 3, but since it's from ocean purpose, we say we need to size it for our location. And first thing to do is to choose the size of the trash, because one of the major pros for the system is that it catches big size of trash. So we did look for the trash size near our location. So we found some data from this location, and we found that, you can see here, that there is a lot more macroplastic than microplastic. So we say, okay, this system is gonna be for catching microplastic, so which is above 200 millimeter. And we also found that most of the debris in this area was mostly plastic, as you can see here, which is half of the graph. So blue is plastic and timber, which is in yellow here. So this is an important data, because mostly plastic and timber, which are mostly at water surfaces, so it's going to be an important data for scale our devices. So now that we choose the size of the trash, the only remaining problem is the possibility to catch fish, because we can adapt net to catch the debris, but we need also to avoid fish. So we kind of look for the type of fish that are located in our location. So we saw there is like 3 layers: upper, middle, and lower layer. And as you can see here, the average size of the fish in the upper layer is between 10 and 30 centimeters. The microplastic is above 20 centimeters. So we say that most fish make it through the net, but we thought about adding escape edge to allow larger fish to exit the system. And actually, since the velocity of the system will be slow, that could prevent the fish from being trapped. So now that we choose the location and the system, to scale our system, we need some important data on the location conditions. So we found some data about the tidal flow. By consulting the periodicity of the tidal phenomena, we can choose actually the period which is more efficient to use our device. We also look for ocean wave height. So in this location, we saw that the wave height is approximately at 1 meter. So it's important to scale and to see the force that will be applied on our system. We also look for the length and the ocean depth to scale our device. And with all of this input value, we kind of think about a method to scale our device. So here you got all the input value that we thought about and that we look for. And then, for example, with trash and fish type, we can actually choose the net side. With the depth of the sea, we can choose the depth of the net, and etc., etc. So this is the method that we choose to scale every our device, and this is what we're going to do more in detail in the final presentation. So with the real data. So we're going to finish to size the technology for our location, and then we're going to predict the amount of production of 9 dB in this particular location and predict the economic aspect of the technology. And this is the job allocation for our presentation. So as you can see, each person kind of search for a specific part of the presentation. So I search for the location, June search for the location condition of treatment, Belgium for the trash and size, and then we kind of gather all of our information to think about the method to scale the device. Thank you for your attention.
No,
Yeah.
So, how are you going to specify your final model? So, in terms of performance of the system, so for example, how many fish how amount of fish can you collect from your system? Is there any system?
Actually, we've got here, so since all of the device of ocean cleanup is quite innovative and new, we don't have a lot of data, but we can say that the system of 3 is actually the second system that they did. The first one is the system O2, and they actually give us like the amount of debris they collect for the ocean. So we can actually kind of do a approximated calculate with that and see with our location, which is like the sea, so it's not as big as the ocean, but we can actually find an approximate amount of debris that we could catch. And since we also, I don't know if it's here, we have data actually about the amount, a number of ocean debris here. So we have data with the data and what Ocean Cleanup did with the system of 3, we can actually find. It will not be a precise number, but it will be a good approximation. Yeah. Yeah, this is, yeah.
Right. Good to see the computation. So one thing is, it's depending on the size of area.
Yeah.
Can I see the page 16?
Oh, this one?
16.
Yeah.
Yes. So you, the triangle it shows us is the area of focus. Or, yes. So it looks like it's a little bit wider area for the interceptors. Right? But depending on the how many debris on the area, say, very rare, say, altogether is only 100, then maybe better for interceptor rather than that. So depending on the area size and also depending on the number of debris from that area, or density or frequency. So your choice can be different. So you need to analyze the area first, more detail. Okay. How wide is it and how many debris are expected in that area? So then you choose which one is better than this one. So you need to start from that kind of.
Okay.
Anyway, I like to see the comparison. Then what is your double location of country?
So yeah, each person kind of focus on one part of the presentation. So I did the location and devices comparison. June did the location condition and equipment. Especially for the location conditions, was mostly Korean website, and I don't know Korean, so it was kind of the easiest choice. And same thing for the we did the trash and food sites. And then we did some meeting to see which device we could choose, and then the method to scale the device.
Anyway, I'm happy to see this team has some kind of collaboration work. Right? And about, thank you. You want? You want? All right.
이거요? 팀 넘버가 있어. 맞아? Hi, this is Team 1, and I will now begin the presentation on tidal energy. First, I'll review the last presentation. We identify the research question and prepare the proposal. So we studied about general information of tidal energy and compare tidal energy with other energy, and research about why Korea should utilize tidal energy, and we set our project goal, which is figure out the best place for tidal power plant in Korea. And we get some feedback such as more numbers in economical perspective and more research for other countries, such as Japan, China. So this is our content today. There are two types of tidal energy: tidal current and tidal range. First, let's look into working principles of tidal range energy. As you can see in the diagram, in the case of tidal range energy, as the high tide comes in, water is pumped behind the dam. Then as the tide recedes, the water is released and the flow is used to turn turbines, producing energy. In other words, it can be considered similar to hydroelectric power generation in terms of its principles. On the other hand, in the case of tidal current energy, the flow of water that occurs during the tidal cycle is directly utilized as a power source to turn turbines and generate energy. In other words, there is no need to confine water using a dam. It can be seen as having a principle similar to wind power generation. Next, we have summarized the advantages and disadvantages of tidal range energy and tidal current energy in the table below. Tidal range can be constructed with a bridge to connect transportation, and it can make additional economic effects such as tourism demand and aquaculture complex, and it can make large-scale power generation. But it needs a high initial investment costs and can make a significant impact on the marine ecosystem. By the way, the tidal current energy has less negative impact on marine ecosystem as no dam is constructed. But installation is difficult due to the strong current, and one significant thing that applies to both that is that they can only be installed in areas with big tidal ranges or big strong currents. So we chose the tidal range energy is more suitable in Korea. So why tidal range energy is more suitable for Korea? The answer to this can be found in the topography of the Korean peninsula. Firstly, the West Sea of the Korean peninsula is characterized by bay-like formation. As the Pacific Ocean water flows into the Yellow Sea, it gets trapped and causing a rise in water level, resulting in a higher tidal range. Secondly, the Yellow Sea is relatively shallow, so the difference in depth becomes significant depending on the amount of incoming water. For these reasons, Yellow Sea on Korea experiences a substantial tidal range, making tidal range energy more suitable for the topography of the Korea. Now let's take a closer look at the type of tidal range energy. Tidal power can be broadly categorized into two main types, single flow and double flow. Single flow refers to the production of energy only during either the incoming tide or outgoing tide, while double flow utilizes both of them. A single flow can further be divided into flow generation and app generation. The following is a comparison of the energy production cost with other energy resources. Looking at the graph below, we can observe the levelized cost of various renewable energies. The levelized cost of energy for tidal energy ranges from approximately 220 to 950, indicating that it is relatively more expensive than other options. However, the cost is highly site-specific and dependent on technology. Look at the next graph. It becomes evident that the majority of tidal energy costs are associated with initial construction expenses. However, maintenance costs for tidal power plant are relatively low. The following image is the Larang tidal power station in France. Larang tidal power station holds the distinction of below the world's oldest tidal power station. Constructed in 1966, and it continues to operate 57 years later. This highlights the longevity of tidal power plants, setting them apart from wind and solar energy sources, which have relatively shorter lifespans than tidal power plants. In other words, from a long-term perspective, tidal energy can offer economic advantage compared to other renewable energy sources. The following are examples of current operational tidal power plants in other countries. First one is Larang Tidal Power Station in France, and second is Annapolis Royal Generation Station in Canada, and third one is Kislaya Guba Tidal Power Station in Russia, and final is Jiangxia Tidal Power Station in China. The table below summarizes the tidal range, basin area, and capacity of these tidal power plants. As evident from the figures, it can be observed that a larger tidal range and basin area are advantageous for generating more electricity. Summarizing the preceding contents, we can discern the key elements required for achieving our team's ultimate goal of selecting the location for the tidal power plant. We need a large tidal range, and we should consider regional electricity production and consumption. Also, we must minimize environmental impact. And various other factors, such as secure a large basin area, features of the terrain and maritime transportation, and surrounding facilities need to be considered. The graph represents the timeline and work distribution of our project. In today's presentation, we did develop deep understanding of tidal energy. So we did the research functionality of tidal power plants and examine historical tidal energy projects and evaluate the pros and cons of tidal energy and study necessary prerequisite cities for implementation. And there is the work distribution, you can see. And ultimately, we need to develop criteria for location selection and identify and evaluate possible locations in our final presentation. Thank you very much. Yeah, this reference
You have a reference list?
I didn't write the reference, but I have a reference, so I can add it after the presentation.
You also can be update and
Okay.
submit by midnight.
Okay.
Another question.
Talking about very beginning, like I said, the closing part. It seems like non-useful data.
Yeah. We use the current tenancy of the title, so it needs to install in the area which has strong current, strong flow, so that we can make energy. So we need to find the place, and because of the current is very fast, so the installation is a little bit difficult.
There is no complete.
I have one comment. So, main goal of your some project is to figure out the best place for kind of how and the player as we mentioned in the first 50. So it is kind of, I think it is kind of optimization. So it would be better to clarify your objective function. For example, SUV must be the lowest, or the size of the electricity generation must be large. So the specific objective function will help audience to understand your project. So I think it would be better to clarify your main target on your next video.
Oh, okay.
Right. Your presentation for me is still in progress. You need to make a decision. If you want to make a decision, you need to have a more analysis and comparison. Otherwise, you cannot make a decision. You should choose the area and choose the location, inside, and
We'll do it at the last final presentation.
it's too late. The midterm presentation, I want to see some rough decision, but we don't have any. No, I don't see any decision made. Did you make any decision? No.
We just make a criteria and we'll do it.
Right, you just survey, still survey, no decision. You
Okay.
should make some decision.
Okay.
Then you need to have a meeting and analysis and comparison. All right. Thank you very much.
And team 2, this is team 2, yes. All right, hello everyone, I'm Kensuke from team 2. We're going to present about our policy making process about hydrogen ship industries. So, as previous presentation, we talked about hydrogen gas is in really important material for any type of transportation, not only ship, but also for making electricity or for people or any other stuffs. But there's no policy actually, and that is one of the issue and the reason why we need to think about proposals or policies for this hydrogen gas resource. And for the previous presentation, we talked about how to create hydrogen gas and also how it will be used in 2050. And in short, 39% of marine fuel will be converted into carbon neutral fuels by 2050. And therefore, we think that there must be some alternative fuels for those shipments or other transportations. All right, yeah. The hydrogen ship industry represents the missing pathway towards achieving sustainable maritime transportation while reducing greenhouse gas emissions. Of course, hydrogens, although it takes a lot of cost to create, they don't emit any greenhouse gases. Greenhouse gas is a lethal gas that penetrates our covered ozone areas. And on top of that, the reason why we're focusing on this sustainable thing is because we're now in moments of period that we need to consider about sustainable or SDG or also so SDGs into our product in order to promote to other people. I'm talking about different directions, but there's a group of people who called IR. It's investment relations. They're not going to invest any product if it's not related to sustainable topics. So if we wanted to develop this high-cost hydrogen ship industries, we need to ask for them to help, which means therefore we need to do some sustainable approach. And therefore, this policy proposal aims to outline comprehensive framework of development, promotion, and safe integration of hydrogen as marine fuel, and also, in short, to create a policy for each emissions, production, and shortage and safety part. So we basically divide it into 3 parts, and this is one of these are 3 jobs that we are assigned. The first one is emission part. This was roughly covered by the previous presentation. The usual emission of LNG, the common gas that we're using right now, has pretty much a lot of chemical and lethal emissions. One of the famous thing is the one that we also emits CO2, carbon dioxide. It seems like, as we are also emitting, it is not that harmful for humans, but if you consider about world scale or greenhouse scale or environmental scale, it is lethal for our planet. So we need to consider about that. And on top of that, there's no regulation on CO2 yet. And hydrogen emits water and heat. So to consider about that, as hydrogen doesn't produce carbon dioxide, this is one of the one of the frontier or key points that we need to consider, reason why we need to apply hydrogen. And the next emission that we suffer from is sulfur oxide, also known as SOx or SOx emissions. This is one of the lethal emissions around the world. This could also kill a lot of animals, or basically this is used on basic oil emissions. So it's designed to be natural thing, but as it contains chemical emissions, it's harmful, and as it is sulfur, it's really dangerous for humans as well. For the for the other one, the other two, we would like to announce about NOx and PM. These two, of course, it's similar to SOx and NOx. SOx is similar to NOx, the nitrogen oxide. This one, it's how do I say? It's not that lethal, but most of the LNG powered ship emits this gas, and which is not sustainable for our planet. So as we highlight in the blue, we would like to use hydrogen in exchange of using LNG, because hydrogen does not also produce NOx. Or on top of that, particulate matter, PM, hydrogen never also results of lower particulate matter emissions. Therefore, considering those four emissions, we think that hydrogen is really a crucial point. So here's really kind of summarized part. Based on the actual regulation announced in IMO, which is a group of regulation, we plan to formulate more stringent emission policy for hydrogen. We still don't have such policy on hydrogen. That's why we are considering to make it. Taking these regulations into account, and this initiative aims to contribute to carbon neutrality and further reduce greenhouse gas emissions. So I've already kind of mentioned about pros about hydrogen, and I believe that you guys think, well, if hydrogen is that positive, then why don't we just use it right now? I already mentioned about one of the cons, which is it costs a lot, but it also has another couple cons. That is, the first one is most of the hydrogen is called gray hydrogen. The gray hydrogen is created by chemical reaction between other chemical that creates CO2. So basically, to create hydrogen, we emit CO2, which is harmful for our planet. So we wanted to produce hydrogen without taking those actions, without using those processes, which is called green and blue hydrogen, which doesn't permit any CO2 or zero CO2 as it's shown in green, or brown where CO2 is captured or stored in other place. Basically, we try to reduce the emission of CO2, or we try to restore into other place in order to avoid using gray, which just emitting unleashed CO2, which is harmful for us. So what is green hydrogen or blue hydrogen? So green hydrogen is hydrogen that produces using renewable energy, like wind energy sources, such as solar, wind power. And this is in contrast to gray hydrogen, which is producing, which uses fossil fuels to burn something to create CO2. So it's, as it names green, it's really eco-friendly. So why is green hydrogen important? Well, I already kind of mentioned about it's not emitting CO2. Of course, yeah. Green hydrogen is important because it is clean, sustainable fuel source. It can be used to generate electricity and power and produce heat. Green hydrogen can also be used to store renewable energy, which can be helped address intermittency of renewable energy sources such as solar and wind power. So basically, we can reuse it to any sort of platforms if we use green hydrogen. And therefore, we need to think about policies. We don't have any policy for hydrogen right now. And that's why we tend to use gray hydrogen instead of green hydrogen or blue hydrogen. And the next one is the policy for storage and transports. There are a couple things to consider about storage when it comes to hydrogen. If you guys learn about hydrogen in science, I think you pretty much know about flammable or inflammability of hydrogen. So it should not be close to fire due to the Dangerous Substance Safety Management Act. It shows that store contains enclosed, well-ventilized, cold place. The reason why it needs to be cold is because hydrogen is air, pretty much vaporized. We need to compress into a cold state in order to make it liquefied. The other one, it says, do not treat above the flashpoint, and also store handles with its static electricity carefully, because all of those materials could cause into fire, which explode entire hydrogen. Imagine that this kind of like small amount of liquefied hydrogen faced with fire, it explodes entire place. So we need to be careful about storage. The other part is container. The gas containers have endure high pressure. As I said, it is vaporized. It's air, basically. We need to compress and cold. So the material needs to be really endurable for high pressure and also cold materials. And hydrogen is leakable and lighter than these gases, so require more strict and safe regulation for it. So the policy that we would like to focus on is find reasonable value, or the regulation for the material that we use for the storing containers. On the other hand, we also want to focus on transporting hydrogen. As hydrogen is vaporized and compressed into to liquefy, it is really difficult to transport into one to other. We would like to propose three states. One is liquid, and the other is gas, and the other is solid. So pretty much it's similar to, in terms of liquid, it's pretty much similar to LNG or other gas, oil transportation. We basically use pipelines or materials to flow away. When it comes to gas, we just need to put into a tank, and for the solid, we just need to store it into metals surface to let them stick into the metal. But this one is, I think, really unreasonable because it's really difficult to. So 1 and 2, the first and second option is really reasonable. Transporting hydrogen, to make hydrogen transportable, it requires a lot of external energy. So again, to make energy or to use energy, you always need to face with a sustainable part. So we also need to think about the regulation about what kind of energy we should use in terms of transportation. And it generates CO2 as well. So it also requires reduced carbon footprints. And therefore, the policy for transports is currently what we research is proportion of transportation method and also help to reduce carbon footprint. Those are two basic policies that we would like to focus on for storage and transport. Before we go into conclusion, let me just focus on LNG policy. So currently, LNG policy has several factors. This one is an example from one country. So it is not unique to like worldwide policy, but it's pretty much saying exactly the worldwide policy is saying. One is site approval, healthy, and safety, financial, like technical and construction and operation, and so on. These all covers the policies that we would like to focus on. For example, proportion of transportation. This is also considered as the healthy and also the material. This policy to find a reasonable hydrogen fuel is also considered as material we use and the place to store. The policy to make a proportion blue and green hydrogen also consists of health and safety. And therefore, for the further research of this group, we would like to do some further investigation about each LNG policies to compare with our policies. So the hydrogen ship industry represents a promising pathway towards achieving sustainable maritime transportation while reducing greenhouse gases emission. But there's no policy regarding this ship yet. So we would like to consider, based on LNG policy, which is the existing policy for LNG and LNG resource, so that we could kind of get some idea from LNG policy and kind of convert into hydrogen version. And those are our further plan for next presentation. So thank you so much.
Other things?
On the policy, what would be the kind of policy? Are you going to impose, for example, regulation of global emissions for example, all of these principles guidance, or you are going to say, okay, so you have to use these kind of techniques to fulfill and to be influence?
That's a really good question. I think we need to discuss that part with my group, but for now, I can say that I would rather do the first version, like make some regulation for worldwide policies, because that is much more achievable for us as an individual to create policies. But I think it will be much better to cover up the second one that you proposed, for the further improvement of our policies. Thank you so much for the questions. Mhm. Yeah. 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 Yeah, I think we should have reduced the text. Yeah, thanks so much.
Other? No? Good.
I have one comment.
Okay.
So you're dealing with the policy of the hydrogen ship, which contains hydrogen fuel ship and hydrogen container. And as you mentioned, hydrogen is multi-type vessel fuel, so there is no regulation. But many classes and IMO are working on the regulation. So, for example, in case of energy, IGF code is the famous one for the energy fuel ship. It means the code for the low flash point fuel. So IMO is trying to add some text on that code about the hydrogen, and also for the IGC code, which means the liquefied gas container. So they are trying to add some contents about the hydrogen. So you're going to make a comparison of energy policies and hydrogen policies, and next time it would be better to read some code, IGC code and IGF code. And one more comment. So as I said earlier, many places are making their guidelines for the hydrogen ship. For example, ABS, the Class of America, so they released the guidelines for hydrogen fuel ship on sometime May of this year, and guidelines for the hydrogen carrier on October this year. So it is released on the internet, so you can find it. It would be very helpful
as a reference.
Make your presentation. Thanks.
Thank you so much for the comment. Actually, I'm really interested in about IMO part. Our group member Yeon-min Ki, he is also doing a hydrogen pursuit on his own this university, and he is really resourceful about IMO and also those parts. I think we should have another discussion about IMO with him and further create some policy by referencing American or those conferences. Thank you so much.
All right. Once again, your team does not show any decision made. No decision made.
Okay.
You need to make a decision, whatever. It can be wrong, but you need to make a decision. Next time. Let's play.
Okay.
Another one is you need to find out the pressure range and temperature range. You need to protect or similarly to the energy carrier, the pressure and temperature is important for it. Also, probably more important for the hydrogen transport.
For the container.
Container. And container decides the design.
Okay.
And ship. So you need to start from what can be the range of pressure and temperature. You need to figure out, solve. see that educator has a two type, most type and membrane type. Do you know?
I didn't know about that. I think I should research.
Because of that question,
Mm.
we have a different type. Completely, sir.
Okay.
Cultural. But I guess the hydrogen may have a more difficult.
Can I ask you a question? So for the decision making, we were really struggling about our direction for decision. What kind of suggestion would you like to give us for?
Say something like that. You need to fix in the pressure range because pressure can be low, high or low. Also temperature can be high and low. You can decide on this type can be good for this range of temperature.
So can we just so I think right now the problem is that we are trying to focus on like emission, storage, production. Can we just focus on one like storage part and then
because storage part is so important for the hydrogen ship. That's why I'm asking you.
Okay. Maybe our group should focus on like the storage part and the pressure, temperature.
Right. It is one portion of the design, but it is so important. You should need to focus on it because I don't see any such
focus. Okay. Thank you so much.
All right. So we have a final one.
Ooh, we are late. And team 3 will be presented by Kim Do-hyun. He's online, so you can share your screen there. Kim Do-hyun, where are you? Right, go ahead. Sharing your screen. Okay, it's coming. All right, so you can start now.
Can you hear me?
Yes, go ahead.
Hello, everyone. I'm Do-hyun Kim, and I'm the mid presenter of Team 3. Our topic is cleaning up oil spills and how to react efficiently. The oil spills are a major environmental issue. Therefore, we need to decide on a method to deal with oil spill effectively. And this is a review of the proposal. We decided on a research topic by focusing on reaction among the stages of oil spill prevention, reaction after oil spill, and protection. We'll find out efficient solutions and plan to apply them to real life. Today I will present our finding of various cleanup methods. This is our contents, cleanup method, and comparison, and conclusion, and finally future plan. These 6 buttons on this slide show 6 different methods to deal with oil spill. There are booms, skimmers, solvents, dispersants, in-situ burning, and bioremediation techniques. First, booms are temporary floating barriers used to contain marine spills, protect the environment, and assist in recovery. Booms help to concentrate oil in thicker surface layers so that skimmers, vacuums, or other collection methods can be used more effectively. There are various boom methods. Containment boom deployment for spill containment requires the placement of a boom in a moving body of water and involves several distinct operations. A deflection boom is used to intercept, deflect, or move a slick towards a more desirable recovery site. A cascade boom is one of the deflection boom type, and exclusion boom is largely a protective measure, the idea being to protect sensitive areas such as marshland, water intakes, or shorelines. An oil skimmer is a device that is designed to remove oil floating on a weaker surface from oil space. The effectiveness of a skimmer is highly dependent on the loudness of surrounding water. There are several skimmer methods. First, where skimmer function by allowing the oil floating on the surface of the water to flow over a well. Oleophilic skimmers function by using an element such as a drum, disc, belt, loaf, or mop to which the oil adheres as the element is moved up through the oil or water surface. A suction oil skimmer works like a household vacuum cleaner on the surface of the water. Booms and skimmers are often used together, and they are easy to deploy. However, they have the disadvantage of requiring calm water surface. In situ burning, ignites the oil at the spill site and thereby removing large amounts of the oil by converting it to CO2, water, soot, and other combustion products. In situ burning method is capable of handling oil spill on icy water, such as the Arctic Sea. Weathering this decreases flame spreading because the difference between the ambient water temperature and the flash point increases. Thus, more heat is needed to ignite the oil. There are safety issues of secondary fire, risk of accidental ignition and explosion on in situ burning. Bioremediations use microorganisms, fungi, or bacteria to decompose pollutants into simpler compounds such as water, CO2. As bioremediation is a less labor-intensive, less expensive process. It completely destroys toxic hydrocarbon compounds and does not transport them to other area. However, it is a very slow process, sometimes takes weeks and months. Some highly chlorinated contaminants and high molecular weight PAHs are not readily amenable to microbial degradation. Solvents are natural synthetic materials distributed on the water surface to collecting floating oil. Then the saturated material must be removed. The advantage of solvents is that effective for shoreline washing will, where other methods are impractical. The disadvantage is discouraged for large-scale use due to excessive oil waste. Dispersant applied by boat or flame break an oil slick apart into tiny droplet smaller than a diameter of a human hair. These tiny droplets then disperse evenly into the water, where they are naturally biodegraded by microorganisms. The advantage of this dispersant is that enhances natural breakup of oil and minimizing surface damage, and rapidly minimize pollution damage to surface resources. However, it's ineffective for very thick oil. We evaluated 6 methods using 7 criteria. These are the items of advantage: inconvenience, cost, effectiveness, speed, pollution, and worker safety and labor demand, respectively. Among these, if you look at the cost column, cost of boom represents the price per meter, and cost of skimmers represent initial invest cost. The rest represent the price required to clean up the oil spill in ton. We gave each item a score of 1 to 5 through discussion. The 2 negative items, inconvenience and pollution, were given a score of -1 to -5. Afterwards, the value added by multiplying each criterion by importance is the score for each method, which is indicated by a blue number on the right side of the table. The results were presented on 2 slides. This slide shows the result score of bioremediation, sorbents, and dispersant. This is our conclusion. The score were concluded by 21 points for boom, 60 points for schemas, 3 points for in situ burning, 60 points for bioremediation, -1 point for sorbents, and 70 points for dispersant. In addition, we briefly wrote down the location where each technology can be appropriately applied. It is concluded that boom are suitable for application in calm ocean, skimmers in various conditions, except low sea, in situ burning in versatile condition except ocean, and bioremediation is same as in situ burning. Sorbents in shoreline and dispersant in dispersing open sea. This score sheet can help us determine the correct action to take according to a given situation. This will help us in the final presentation, where we will talk more in detail about the accidents themselves and what can be done in each case, now knowing the strengths and weakness of the studied method. This is our future plan for the final presentation. First, we will search regions or conditions where oil spill occurs frequently. And second, choose 2 or 3 more mostly important regions by giving score. Third, analysis of each regions and condition. We will calculate specific number, for example, cost, efficiency, dimension, according to the condition. And finally, we will determine the correct action for each regions or each conditions. This is our job allocation for midterm presentation. Farrell worked on sorbents and dispersant techniques. I worked on boom and skimmer techniques. Since I am a mid presenter, and I have completed the slides and prepared the present. Park work on in situ burning and bioremediation techniques. all of our team had a discussion to evaluate the score of each technology. So thank you for listening.
You. Question from other team members? No. Then because of time, TA and myself will raise or comment and questions through the Kakao. Right? Great. Thank
Okay.
you. See you next time.